Okay, so this video is for the next quiz, which is pretty crazy. So first, let's set this. These are all the equations that you need to know, and it's quite a lot. So first, we have these equations: the angular or uniform centripetal force problems. These are the equations you need to know. Pretty much S is substituted for theta, velocity is substituted for W, and acceleration is substituted for alpha. And it's pretty much the same. The units for theta, radians, right? W, radians per second, and alpha, radians per second squared. Then we move on to the terminal velocities and stuff. These are all the equations that you need to know, which is quite a lot. These are kind of the same thing. It's just using this one instead, the time constant. We got Vt equals mg over b, ma equals mg minus bv, and all of these pretty much. So that's all the terminal velocity equations you need to memorize. And then for this is for the conic pendulum, tan theta equals v squared over rg, and ty equals mg, right, because it's up, and then tx is the centripetal force over r. So that is pretty much all the equations you need to know. So now let's get into some actual problems. All right, so in this equation, or this problem here, we have Grayson's Toyota on an embankment, and we have to figure out the friction that it is going, or the friction that is being enacted on Grayson's car here. So, well, what do we have to do? Well, we have to set up the forces and make them cancel out. So the force going up the ramp is going to counteract with the force going down the ramp plus friction. So we can write this as Fu, or force up, equals force down ramp plus friction. So now we can set up all those things. And the thing we have to memorize with embankment here is embankment has two normal forces. The regular one, right, that goes, which is mg cos theta, right, which goes that way. But we have to also take into account the normal force for the embankment. So let's write out this equation. So let's set this up as force up is going to be mv squared r, and it's going to be cos theta, and that is going to equal the force down the ramp, which that force down the ramp, well, what is that? We know how to do that. It's mg sine theta. So mg sine theta plus friction. Well, friction, the coefficient, right, times the two normal forces added together. So what's the first normal force? Well, it's mg cos theta, right? And then our second normal force is going to be plus its centripetal force, mv squared over r, and it's going to be sine theta. Because, right, we have this, and then it goes like this, and then that is our triangle, right? This is theta right here. And if we're trying to find normal force, it's going to be this one right here. And what is that? Well, that's opposite over hypotenuse, and that is, what is that? SOHCAHTOA, that's sine. So we use sine there. So that is pretty much our equation. Now we can plug in all the variables here. So, by the way, the m's, we're not given m, so we know that it's going to cancel out. So we can cancel out all the m's, and we can set up our equation as v squared, which we're given v, which is 89.5 squared over r, which is 316.5 cosine 31.2 equals 9.81 sine 31.2 plus friction, which is our x, times 9.81 cosine 31.2 plus 89.5 squared over 316.5 sine 31.2. Now this is an incredibly long equation, or we use numeric solver, and I'm not going to put you through that, but pretty much you come out with our friction coefficient as 0.770. So, but pretty much here with the embankment, you have to know how to set it up, and that's the hardest part. Once you set it up, you can just do numeric solver, and if you get it wrong, it's literally calc error, so it's not that bad. So that's how to do an embankment problem. Okay, our next problem is a pendulum, conic pendulum problem. So we are given that a pendulum swings and it creates an angle of 54.5 degrees, right? This angle right here, and it's spinning. The mass is 450 grams, and we have to find out what the T is. So pretty much we know that this is Ty and this is Tx. And we have our equations that we have up here, hopefully memorized, right? So what can we do from here? Well, we can set up some things. So Ty is going to equal mg. So Ty equals, what is m? Well, let's make sure to convert to kilograms. 0.450 times 9.81, right? So we get 0.45 times 9.81. That comes out to 4.41. So Ty equals 4.41. Now we could think about this. We could expand this Ty into something else. Well, what is Ty? So here's our theta. So we could use pretty much like the r sine, r cos theta, right? That we learned previous back. So here's our theta, and we're trying to find the y here. Well, what is the y? It is adjacent. So SOHCAHTOA, right? Right? So adjacent over hypotenuse, right? That is going to get us our Ty. So adjacent in this case is going to use cosine. So it's T cos theta, which is 54.5, equals our Ty. What is our Ty? We just found it, 4.41. Now we can just divide by cos on both sides. Cos 54.5, cos 54.5, and our T comes out to, let's see, 4.41 divided by cos 54.5. Oh, that is, oh, I know why. I'm in radians. Our cos comes out to 7.6 newtons. And that is how to do a conic pendulum question. So, okay, our next question is a Ferris wheel problem. So, in this Ferris wheel, it normally spins at 2 rotations per minute. The acceleration at this point, right here, it starts accelerating, is 0.0250 radians per second squared. And the question asks, what do you feel at pi radians and at 2 pi radians? Well, let's set this straight. So at the top, you feel gravity minus centripetal force, and at the bottom, it is gravity plus centripetal force. So these two, you kind of just have to know that these are what they are. At the top, it's G minus AC, and at the bottom, it's G plus AC. And now we can actually start solving for this. So what should we do first? Well, let's try and find the W, right? Or the W, the velocity at which the initial and final at which it goes from here. And 1 pi radian, pi is 180 degrees, right? So that's just going to be half rotation, and then 2 pi is 360, which is a full rotation. So first we're going to find it at the bottom. So W theta is going to equal, well, we can change this 2.0 times, right? There's 1 rotation and 2 pi, and there's 1 minute and 60 seconds. So that's just simple converting. And so 2 times 2 pi divided by 60, and our W comes out to 0.209, and that is in 0.209 radians per second. So that is our W initial, right? So let's just set that to the side, 0.209 radians per second. And now with that, we can solve for our W final. And what equation can we use to do that? Well, let's do the WF squared equals W naught squared plus 2 alpha. My alphas are really bad, sorry, theta. And we have all of these except for WF. So this comes out to WF squared equals 0.209 squared plus 2 times our acceleration given 0.0250 times theta. Well, what is theta? Well, let's first start with pi radians. And we can do numeric solver there, or just plug that. Our WF comes out to, it comes out to 0.448 radians per second. Now, with this WF, we can solve for centripetal force because we know that AC equals W squared R, and we have R, and we have W. So AC equals 0.448 squared times 20. Let's do that, 0.448 squared times 20. And our AC comes out to 4.01, right? Meters per second squared. Now with our AC, well, what do we have? So 1 pi radian, right, like I said, is 180 degrees. So if you're starting from here, pi radians ends you up here. So that's G plus AC. And we have both of those. So 9.81 plus 4.01. 9.81 plus 4.01. So the force you're feeling is 13.82, right? Newtons, or 13.8. And then, so the question asks, what do you feel in G's? So how do you find G's? Well, you divide the force you're feeling by gravity. So that's 13.8 divided by 9.81. And this comes out to 13.8 divided by 9.81, 9.81. This comes out to 1.41 G's that you are feeling in pi radians. Right, now if we want to find 2 pi, you do the exact same thing except you plug in a 2 here. So WF squared equals 0.209 squared plus 2 times 0.0250 times 2 pi. And you should come out to WF equals 0.598 radians per second. And your AC comes out to 7.15. And then at 2 pi, it's a full rotation, so it becomes G minus AC, so 9.81 minus 7.15. So 9.81 minus 7.15, and you get 2.66 divided by, because we're finding G's, and we get, you are feeling 0.271 G's of force in 2 pi radians, or 1 rotation. So that is how to solve that. So continuing on the Ferris wheel, the next question asks how many rotations for you to pass out, or in other words, how many rotations to reach 9 G's, which is apparently the G's you feel when you pass out. So we have to pretty much reverse engineer this. So how do we normally find our G's? Well, it was the force divided by 9.81 equaled our G's that we were finding, the force that you're feeling, right? So here we can plug in the 9 for the G's. So F over 9.81 equals 9 G's. And then we can pretty much multiply, so 9 times 9.81, right, algebra. And the force, total force you're feeling is 88.3, right? So that's the force you're feeling. And at 9, so how many rotations? So pretty much you are going to try and find the W now. So, or centripetal force. So AC equals W squared times R. Okay, so we're finding AC, right? So how do we do that? Well, the force here at the top is going to be 88.3 minus one of the G's, right? Because it's at the top, so 9.81, right? And this becomes the force equals, or the AC rather, equals 78.5, right? And so 78.5 equals W squared times 20, right? Because we know R. And we can divide by 20, so 78.5 divided by 20. That's that, and then we can square root that, right, to get W final. W final equals 1.98 radians per second. So now with this W final, after finding reverse engineering to find the AC and stuff, we can set up our equation, which is 1.98 squared equals our W initial, right, which we found way back then, which is 0.209 squared plus 2 times 0.0250 times our theta, because, right, that's what we're trying to find. We're trying to find how many rotations. So let's plug that into numeric solver, and you should come out with theta equals 77.5 radians. Right, now if we're trying to find rotations, we can convert this radians into rotations. So 77.5, there are 2 pi radians in 1 rotation, right? So let's do that. 77.5 divided by 2 pi, and you should get 12.3 rotations, right? So let's think about this. We have our Ferris wheel here, and we're starting here. So 1 rotation, 2, blah, 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 all the way to 12. So we're at 12. And then 0.3, well, that's, you know, let's just say it's like here. If that's 0.3, we're trying to find another full rotation to reach G's. So we can round up, always round up to, so 12.3 is going to round up to 13 full rotations to actually reach 9 G's. So our answer is 13 rotations. Okay, our next question involves terminal velocity with Ani. So Ani weighs 61.3 kilograms. Ooh, skinny Ani. And he reaches 67% of his terminal velocity in 3.24 seconds. And we are tasked with finding the B, the time constant, and the VT. I'm just going to call this squiggly to make this easier. So we have to use those equations that we set up. So we can we can use the VF equals VT times 1 minus E, and then negative 3.24, right, over squiggly. Right, so what do we do with this percentage here? Well, 67% of his VT, right? So we can divide VT by on both sides, and we get VF over VT. And what is that right there? Well, that's a percentage, right? So this comes out to 0.67. And so we can rewrite this as 0.67 equals 1 minus E to the negative 3.24 over squiggly. Now, we can just use numeric solver here to find squiggly, and eventually we can find that squiggly is equal to 2.92 seconds. So that is how to find squiggly. Now we can use our other equations to find B and VT. So first, let's find B. Well, we know that squiggly equals M over B. And we know Ani's weight, which is given, and we know the squiggly, which we just found. So 2.92 equals 61.3 over B. And we can just do simple algebra. 61.3 divided by 2.92, and we get 21.0, and the units for B is newtons second over meters. So that is how to find B. And finally, how do we find VT? Well, we can use the equation VT equals mg over B, because we have all of these variables. So VT equals M 61.3 times 9.81 over our B 21.0. And our VT comes out to 28.6 meters per second. And that is how to use terminal velocities and all those equations. Thank you.